Okay, this is from the last year Stanford math tournament from the algebra problem set. This problem asks that what is the remainder left when you divide x to the sixth power by x square minus 3x plus 2. So at first I thought that, oh well, we'll use the remainder theorem, but that didn't quite work out for me that well. So I figured I'll do it in a more organic method. So here it is. So we know that our main polynomial, the dividend, I think that's what to call. This is the quotient times our g of x, the divisor, plus the remainder, right? We know this, So, from this, we can work towards this. So, p of x is, of course, x to the sixth power. This is equal to some quotient q of x minus g of x, which is this x square minus 3x plus 2 r of x. Now it actually turns out that we don't need to do all this, right? Yeah, it only turns out we just need to plug in 0 for this, as we do in the remainder theorem. But you see, I don't know about people, right? But what I did naively wrong is, see, now this is quite easy quadratic, I'd say, So we factor it by splitting the middle term, as it's called in my school at least, so minus 3x, right? So what we have to do is find two numbers a, b, such that their product is equal to 2 times the coefficient of the x squared term, but that's 1, so we just ignore that. And a plus b is their sum is equal to the coefficient of the x term, x to the first power term. That's minus 3, and that's quite easy. You can say, and these are commutative, of course. So a can be minus 1, and the down first. A equals minus 1 and b equals minus 2. That makes sense. Because see, minus minus, they cancel out, right? And then when added, they add up to minus 3. And these are interchangeable because addition and multiplication both are commutative. So yeah, we move on from this. So we've got these things. So we factorize this now. X square minus 1x minus 2x plus 2. And this is 0. Yeah. So we get x times x minus 1 minus 2 times x minus 1 equal to 0. And we get x minus 2 times x minus 1 equal to 0. So yeah, this is our factorized polynomial, our factorized g of x. So yeah, x minus 2, x minus 1. So that means that x is either equal to 2 or 1. Right? Those are valid solutions. But you see, here's where I went wrong, right? So like 2 and 1, these are valid solutions. But what we do in our school is, we've been taught that, you just plug in p of this. So p of, say, whatever this is, so p of 2, and then you just get the answer. But that's not how it works here. Because you see, even you might have learned this, but that's not how it works here. Here because this, our g of x, is a quadratic polynomial, we'll have to do something else. Now we'll see what we're going to do. So what we do is, we take our p of x. Well, not p of x. Let's not enter the wrong value. Let's call this solution a. So p of a, we take that. Now in general, what we do is you just do this, and whatever the answer is, it is simply the remainder. But this is for linear only. This is not true. This is for linear g of x. That's what it is for. But what we do here is it's a bit different. It's not that different. What we do here is we still take p of a, right? But we set that equal to ax plus b. Because we have two solutions, we can't just neglect the other solution. That would be wrong. So let's see, right? We'll take p of the first one, so let's take the p of 2 first. So p of 2 is a... oh, now, sorry, there's a mistake here. I entered ax. This is supposed to... oh, this is... oh, yeah, actually this is right. I think I'm correct, right? When I'm saying p of a, right? That should be ax plus b. No, wait, is my notation correct? Because isn't that just constants? Because I know this is going to be like 2a plus b. Let's just call this c and call it a day, because I don't want to, create ambiguities. Let's call this c, huh? So we call it ac plus b, right? That's what we'll use here for quadratic, right? So p of 2, now you know what p is. So p of 2, that would be 2 to the 6th power. That's 2a plus b. That's nice. That's nice. And 2 to the 6th power, if you can do math, is 64. 64 is 2a plus b. And now for the second one, we'll solve for p of 1, which is just 1a plus b. So we have 1 to the 6th power equals a plus b, and we have 1 equals a plus b. Now we can simply plug in, we can use this equation substitution. So we say a is equal to b minus 1, if I'm not mistaken. Or is it 1 minus b? It's 1 minus b, sorry. I am indeed mistaken. 1 minus b. That's nice, right? Then we plug this in here. So 64 is equal to 1 minus b plus b. Now 2 times 1 is 2. 2 times minus b is minus 2b plus b is 64. 64 is right, so minus 2b plus b is minus b. 2 minus b, right? That's right. And we move the minus b to there, that becomes a plus b. So let's see, 64. No, not 64. Okay. Minus b plus 2. Let's reverse the signs on both sides. Let's call this b minus 2. So b is minus 62 if I can math correctly. And from that logic, right, b is minus 62, then a should be minus 61. Wait, what? No, a should be 63. Yeah, sorry. My brain just melted there. Equal to here 1 plus 60. No, I'm wrong. I'm so wrong. 62 is 63, if I'm not mistaken. Right? Yeah, I think that's correct. That sounds about right. So, and this is not it, right? We're not told to find the values of a and b. We're told to find the value of r. And as you know, r is a x plus b. Right? So, yeah, we know r is 63x minus 62. So that was it for this video. I hope it wasn't too bad. I tried to improve the quality by moving from portrait mode to landscape mode, which is, yeah, I think that's going to improve the quality overall. It should. I hope it is. I really do. Yeah. And yeah, I hope you like this. It was quite short, but well, it was a good one, right? Oh, and why do I end it here, right? Why would I? Right, let's say we have a polynomial, whatever, p of x, divided by some g of x. Let's say the degree of g of x. Now we know if the and d of let's call this the deg function of g of x, right? If this is equal to 1, right, then well then we know what we do, right? We know that r is simply a constant. You know, that's a good argument. R is simply a constant a. But when the degree of g of x is 2, i.e. g of x, our dividend or divisor, I don't quite remember it, but it's the denominator. Basically the denominator is quadratic, right? Then we know that r is in a linear form, it's not a constant anymore, and basically the degree of g of x, see, this is n. Then we know that the degree of r, so here it was 1, here it's 0, here it was 2, here it's 1. So we know that the degree of our r, let's call this r of x, degree of r of x is going to be n minus 1. That's brilliant. I mean, that's pretty good. That's like an expansion of the remainder theorem, if you've been learning that in school. I mean, I have, so yeah, I'm pretty happy with this, and I might be uploading more such Stanford math problems because I'm like preparing for this competition. I really like it, I'm interested in it, and yeah, there's so about now on your screen there'll be a calculus video. It involves haram there, and you must watch it. If you don't, then you hate animals. So yeah, watch that one, and dab.